Every year, millions of electronic screens and devices become waste. Inside them are valuable materials that are difficult, slow, and expensive to recover. RoboLoop is changing that by using robotics and artificial intelligence to automate the dismantling of electronic waste and unlock a more sustainable future. Electronic waste is one of the fastest growing waste streams in the world. Recycling it is challenging because taking apart devices like flat screen TVs is still largely done by hand. It is labor intensive, time consuming, and costly. In some cases, it can even take more than 10 minutes to disassemble a single screen. That bottleneck limits how much material recycling facilities can process and how much value they can recover. RoboLoop solves this problem with intelligent robotic disassembly designed specifically for e-waste disassembly. Using computer vision and machine learning, RoboLoop's robots identify fasteners, locate components, and remove screws quickly and precisely. What once took minutes by hand can now be done in a fraction of the time. This is not experimental technology. RoboLoop systems are already operating in real recycling environments, helping facilities process large volumes of electronic waste more efficiently and consistently. RoboLoop's roots in Pittsburgh and its origins at Carnegie Mellon University play a critical role in that success. Being part of one of the world's strongest robotics ecosystems gave the team access to cutting-edge research, talent, and a community built around turning ideas into real systems. As RoboLoop grew, the Robotics Factory helped bridge the gap between research and commercialization. It provided the space, tools, and support needed to iterate quickly, build production-ready systems, and scale from early prototypes into deployed solutions. The technology itself was built on years of research combined with hands-on industry experience. Robots are trained to recognize different devices and predict where the key components are located, even when products vary in design. Workers load devices into the system, and the robots do the repetitive, high-precision work needed to separate materials cleanly. The result is better recovery of metals, plastics, and electronic components that can re-enter the supply chain. RoboLoop's impact goes beyond speed. By automating the most difficult parts of disassembly, recycling becomes more economically viable and scalable. Human workers are free to focus on higher value tasks like system oversight, quality control, and process improvement. The long-term vision is for a circular economy where electronic waste is no longer a problem, but a resource. Today, RoboLoop is starting with flat panel displays. Tomorrow, the same approach can be applied to many other types of electronic devices. RoboLoop shows what is possible when robotics is applied to real-world problems. It is proof that automation can drive sustainability, efficiency, and economic value all at the same time. This is the future of recycling powered by robotics.